Every sort of action in the world has physics of motion behind it. These physics are seen anytime anyone does something in both real and fictional universes. For this project, we decided to take the fictional route and show the complexity of motion that is used to create modern video games. The video game we chose was Super Smash Bros. Brawl, which was released by Nintendo in 2008. It is important to know that motion in video games is not created individually, but rather by different brands of engines that are used in multiple different video games. Think of the difference between these engines like the differences between Google and Bing, where they both have the same concept but are just set up differently. One thing that all these game engines have in common, though, is that they base the movement in the game they are creating off of many different aspects of physics of motion that can be seen in the real world.
We have learned a lot about motion this last term in class, and many of the ideas are shown throughout the game. One topic that we talked about in class is the effect that weight has on motion. The definition of weight in the real world is the downward pull on the mass of an object. In the game, weight has a huge effect on the statistics of a character. It is usually considered a better advantage to be heavier, but we will show the pros and cons of both. In this example, we will use the heaviest character, Bowser, who weighs 120 pounds, and the lightest character, Jigglypuff, at 12 pounds. One of the many noticeable pros of being heavier is that you tend to give more damage. As you see now, after both characters use their basic attacks, the heavier fighter tends to get a few more points damage than the lighter one. After a while of fighting, both characters gain momentum, and there is an even bigger difference in the damage given by the heavier characters when compared to the lighter characters. Another advantage is that the heavier characters are not as affected by getting damage as the lighter characters. See now, when a lighter character is hit, they move a farther distance away than a heavier character is hit. However, the large advantage that being a lighter character has is that their average velocity is much higher than the heavier characters, and it is easier for a lighter character to increase their velocity.
Another topic in this game that brings up speed is the gravity that is used for the motion in the game. The real-world definition of gravity is the force that objects exert on each other because of magnets. The part of this game that shows how the concept of gravity works most is how fast each of the characters fall. Look what happens when we compare the fighter Fox to another character, Samus. See how much faster Fox falls after jumping when compared to Samus. This happens because Fox has the highest gravitational acceleration in the game at 0.175, and Samus is much lower on the list at 0.058. It is also important to note that higher gravity characters also reach their top falling speed faster. This large difference also affects the height that they jump at, because two characters with the same jump force will not jump at the same height if they have different gravitational accelerations. Gravity also affects something called the knockback effect, which was also talked about when we discussed weight. A character with higher gravity will be knocked back farther, but this effect is more largely affected by weight.
Many aspects of the physics of motion that we learned are found in this game. However, there's one move that can summarize what we have recently learned about motion. This attack is called the Falcon Punch. It starts by the fighter, Captain Falcon, moving his arm backwards and having a massive buildup of potential energy to get ready for the attack. He then converts the massive buildup into one large kinetic energy-filled punch. This shows the use of the law of conservation of energy, which states more or less that energy is not created or destroyed, yet it is transformed. Now you need to understand, this is probably the most fictional part of this game, because it is estimated that the punch travels at 3,600 miles per hour, and the force needed to create the punch is 70,000 newtons, which means that Falcon does an inconceivable amount of work. Compared to the most popular superheroes, this attack of Falcon's has a punching force 79 times greater than what is thought for the strongest superhero. Also, after he punches his victim, the leftover energy is converted into inertia, and after completing his attack, momentum is increased drastically. It is clear that many concepts important to what we have learned in class about motion apply to many things.
The most important concept when it comes to physics of motion is Isaac Newton's three laws of motion. The first of these laws is that an object in motion tends to stay in motion, while an object at rest tends to stay at rest unless acted upon by an outside force. In the game, one simple example of this is when a character is in motion and they are hit by an opponent. It causes them to stop moving in the direction they were going. Instead, the character that was hit is repelled backwards and stopped due to gravity. Now watch when this is applied to an object at rest and see how they no longer stay at rest but propel backwards like it did in the other situation.
Of laws of motion states that force equals mass times acceleration. While it may seem hard to relate a math equation to a video game, the concept of this equation can be easily shown from the game. The idea basically states that when a heavier object is thrown or used at the same speed as a lighter object, the heavier object has more of an impact. In the game, this notion can be displayed when you compare a fighter's normal attack to the attack when they are holding an item. For example, watch as Peach hits her opponent with her basic attack and then notice the damage she gives. Now, Peach will grab the baseball bat and hit her opponent again, and the amount of damage she gives will increase because the baseball bat can attack with more force than she can by herself since it adds more mass.
Newton's laws of motion states that every action has an equal and opposite reaction. The easiest way to understand this is to look at the final smash of a character. A final smash is a character's specialty move, which is more powerful than any of their other attacks and basically makes the character with it invincible. While this specialty move is extremely fictional in most cases, it can still relate to the basics of Newton's third law. As you can see from watching the clip of this move, it starts with an action and ends with some sort of reaction by the opponent. It's important to realize in this move that the same force that makes the attack is equal to the damage gained by said opponent.
We know that it must be difficult to think that science actually has a large part in the creation of video games. However, we hope that this presentation was able to open up your mind to the physics can truly be related to any sort of action. The main thing any person needs to know about motion is that every action, real or fictional, has some sort of physics of motion behind it.